All right, everyone. I think everybody who is going to come has probably already made their way in. But my name is Jake McNeal. I had a brief opportunity to introduce myself last night at the banquet. I'm a graduate research assistant at Stoneville, working with Dr. Crut's irrigation management. Much like everyone else's breakout sessions today, ours on polyacrylamide in agriculture. We're going to split it up between myself and Mr. Pete Hunter here. I'm going to be giving the research side of our data, talking about, what polyacrylamide is, why we use it, and some of what our results were over 2 years, both from a environmental sustainability standpoint as well as profitability. So if you've been in or around the Delta for any amount of time over the past few years, you've probably seen a lot of this information. Over the past 100 years, we've seen a huge increase in agriculture, and particularly in the past 60 or 70 years in irrigated agriculture. I wanted to give you a few raw numbers, such as like in 1965, for irrigation purposes alone in the Delta, we were withdrawing 133 million gallons per day. But in 2000, we've taken that to 560 million gallons a day. With how things have gone in the past 15, 16 years now, I would say that we're already north of that. But we are more profitable than we've ever been. We're producing more food, more fiber than we ever have, and we're still adding to the number of irrigated acres that we have today. Largely, we're doing this through non-sustainable irrigation practices. Now, over the past few years, a lot has been done to bring awareness and technology to the point of implementation in the field to become much more sustainable. We can't operate as if our aquifer is somehow inexhaustible when it isn't. So if you look here, we call these zones of depression. This just simply means that we're withdrawing more water during the growing season for irrigation purposes than can be replenished during the winter months. So again, these zones of depression here, looking ahead to 2038, this is the potential situation we're going to find ourselves in if we do not continue to become more efficient with how we go about irrigating. 80% of the acres in the Mid-South are furrow irrigated. This makes sense from the standpoint that it is our best way of irrigating or watering a large amount of acreage in a short amount of time, but it's pretty inefficient overall. 50 to 60% efficiency on the good end, and we've grown accustomed to somehow thinking that that's acceptable. That's what we have to work with. But when you think of it from the standpoint of that's using twice as much water as you really need to, we're really going to have to start doing something. So we're continually looking at means to improve our irrigation efficiency, and so that's where my research has come in. So I want to give a quick overview on polyacrylamide. Some of you, maybe most of you, are familiar with it, and you may be a little bit more familiar with it than you realize. It is often used as a cleaning agent for fruits and vegetables in the food industry. Why? Because it has an affinity to bind with soil particles. It's dirt if it's on a piece of fruit. If we're talking about it from a agronomic standpoint, we certainly have to call it soil. And it has been proven effective in the western U.S. To promote aggregate stability. We're looking to improve irrigation application efficiency, mitigate erosion, but what about the impact on yield? This is something that to this point has not been looked at very heavily, certainly not in the Mid-South. But why do I make that distinction of the western U.S. versus where we are here? You are going to run across similar soil textures, soil types, but our cultural practices vary significantly from how they do things out west. What that means is the more that you till, the more frequently you till, the less organic matter you're going to have, which is an indication of soil structure. Those two together are going to affect how water enters and then works through your soil profile. So with that, we were tasked with evaluating a polyacrylamide product by the trade name Retention. This is a 30% AI emulsified formulation from Helena, and designed to do those exact things: increase water use efficiency and improve or maintain soil structure where we don't have much organic matter whatsoever. This is applied through irrigation systems. It can be applied through a pivot. We evaluated it in furrow through an electronically metered injection pump. So if this looks something like an IV line, that's exactly what it is. It's administered through almost like a pulse going into your poly pipe, and the agitation as it goes through your pipe is more than enough to bring it into solution. So as an anionic formulation, meaning an overall negative charge, it flocculates soil particles in your surface water simply through opposing surface charges. Opposites attract. It preserves pore space at the water-soil surface interface, and at the same time, due to that, it's going to increase infiltration and extend water availability in your soil profile. It also increases water movement laterally in your furrow. Think about reducing the surface tension of water. It's going to push your water plume to the sides of your furrow bed. Not all of your root system is directly in the middle of your furrow underneath, and so this is going to increase your root system contact with your water. So like I said, I'm going to talk about this from the standpoint of how we went about our research, and we were pretty straightforward with how we went about this. We just wanted to assess retention effects on surface runoff and infiltration, erosion, off-site nutrient transport, both from a standpoint of crop health as well as off-site pollution, and of course corn yield, with the overall goal of we want to become more efficient irrigators in everything that we do. Reducing erosion, reduce off-site nutrient transport and pollution, and maintain or improve yields using less water. So our procedures, our materials and methods were also really straightforward. We set up a 2-year study in Stoneville, the Research and Extension Center there, on 2 different soil textures, a silt loam and a silty clay loam. We were particularly interested in our silt loam soils. These do represent some of our most fertile soils that we have in the Delta, but they can also be some of the most problematic when it comes to irrigating. And they have a tendency to form those nasty little surface crusts right at the surface. And it takes a very little rain event or your first irrigation event to make that happen, and it's already set in. We had a non-irrigated treatment, a controlled conventional irrigation, and retention applied at 10 milligrams per liter. These pictures show a little bit about how I went about that. We did have a small plot environment. The reason for that being we needed to have complete control over every drop of water that we sent down the furrow and be able to capture every bit of it that came off in the tail ditch. Doing that, it's a simple subtraction of how much water actually got in the soil profile. We took water samples at discrete intervals throughout each irrigation event and sent those samples to the USDA lab in Oxford for water analysis and sediment and nutrient analysis as well. So we'll move into our results pretty quick here. This graph is going to show you infiltration pooled over year and site, everything together in one graph, where we saw a 7% increase in overall irrigation application efficiency. For each irrigation event, we applied 4 acre inches and conserved over 6,700 gallons per acre. Now, just to hear me say 7% off the top may not sound like a whole lot, but what this means is you're going to have a 7% savings in fuel cost to run your well motor, as well as a much more direct impact on yield, which I'm going to talk about here in just a second. From a standpoint of erosion, this graph here breaks everything out by soil texture and year. We saw a little bit more variability in terms of reducing erosion, but the trend is still there and presents a very real conservation benefit of 21% reduction in transported sediment, or almost 680 pounds per acre. So we're looking at this from the standpoint of cost savings as well, and it is sometimes difficult to tag a dollar value amount to erosion, to the cost of erosion, but in talking with our extension specialists, extension agents as well, I'm coming up with $4.30 per ton of transported sediment. And so what that's going to look like to your bottom line, I'll talk about again here in just a minute. But from the standpoint of yield, what we're probably all concerned about from an economic benefit, retention also had a very positive impact. So if you want to look at our overall yield numbers, that's fine. You're probably not going to be impressed overall. We were sometimes limited in getting in the field exactly when we needed to for timely irrigations. However, the effect that retention had on yield is the only thing that we were really concerned with. And the effect is still there, very much still there, just as if it would have been if our yields had been much more of what you would expect from irrigated land in the Delta. On our Dundee soils, or silt loam soils, we were averaging almost 12 bushels an acre a head and a little over 13 bushels a head on our Forestdale soils. So on this previous graph, I averaged everything together in terms of yield. I wanted to throw this in here to show you by site, by year, retention consistently out-yielded our water-only irrigated crops every single time. I pulled this 395 value for corn, reflecting an average of prices headed to the elevator in Greenville this past September. Retention is going to cost you $22.93 a gallon with a rate of 2 quarts per acre and a recommended application of 2 per season. That $22.93 represents your per acre cost of retention each year. With that 12.5 bushel benefit at $3.95 a bushel, after you pay for the cost of the product, you would have been ahead $26.45 an acre. So I want to put this on a little bit larger scale for everyone. Let's consider 1,000 acres of corn. That 7% improvement in irrigation application efficiency is going to come out to $3.78 an acre. Now that value comes from a 21-cent per acre inch applied savings. So if we stay at the 18-inch value that we're currently have for corn, cotton, and soybeans in the Delta, you're going to come out to $3,780 on that 1,000 acres. For erosion, again, at that $4.30 per ton, at a 21% reduction, you're looking at $1,462 conserved per that 1,000 acres. 12.5 bushel benefit on corn at that $26.45 per acre after the cost of the product is already taken out. $26,450 is what you would have looked at for a total benefit on 1,000 acres of a little over $31,000. So to bring this back on a per acre scale, 7% increase in irrigation application efficiency across both soil textures, an average of 21% savings in erosion, and a 12.5 bushel per acre benefit. Altogether, you're looking at $31.69 an acre coming out ahead after you pay for the cost of the product. If there is, from a recommendation standpoint, if there's anything I can get you to take home, it is that this needs to be applied before crust formation on those silt loam soils or immediately after furrow prep. I don't think this is a big problem because we do a lot of furrow prep for one reason or the other before plant or immediately after planting here in the South. Again, I recommend 2 applications per season with no more than 25 to 30 days between those applications. The reason being, retention is going to have a soil life, or a shelf life, if you will, of about that 25 to 30 days in your soil where you're going to see this type of benefit that we're talking about from the standpoint of your irrigation efficiency. Past that point, you're still going to see a benefit, but it's going to start to take a nosedive. So 2 applications, you want to back that up around that anywhere between 3 weeks to 30 days to get a little bit of an overlap between your 2 applications, and you're going to see the type of results that we showed here. We do have some news. EQIP 450 cost share program. All of the economic data that I've talked about so far has been from the standpoint of you paying for the cost of the product completely yourself. But EQIP is coming on, going to take up some of that cost, and then your profitability would be increased that much more. So with that, I'm going to wrap my talk up. Since it represents the entirety of my master's research, I just wanted to take the time to say thank you to everyone in the irrigation research group at Stoneville, the USDA lab, Dr. Wade Steinreed and Dr. Martin Locke took care of all the sample analysis for us, and to Helena for the support and funding of this research. With that, I'm going to go ahead and hand things off to Mr. Hunter, and then he and I will both answer questions at the end, whatever.